Yeah. Yay. All right. Well, hi, everybody. Welcome. Welcome to Family Astronomy, and we're going to talk about galaxies tonight. Yay for galaxies. Well, hi, everybody. Welcome. Welcome to Family Astronomy, and we're going to talk about galaxies I need to do tonight. Something. Yay for galaxies. Well, hi, everybody. Oh, that was scary. Can you still hear me? I hope.
Yep.
Yes. All right. My name is Judy Meyer. I am a member of the program staff at the McDonald Observatory Visitor Center. I am also part of the K-12 education team, and I'm happy to welcome all of you who have joined us tonight. And let me introduce the rest of our team. In the classroom, we have Sam and Joe. Sam and Joe, wave your hands. There we go. Sam Jones is our very newest staff person. And so we told her, yeah, we all do these all the time. And she said, okay, so here she is. And Joe is not our newest staff person. Joe's been here a long time. And if you've watched some of our other live streams, you've seen him before. And then out in the telescope dome, we have Saul Rivera. Hello, Saul. And Saul is using are you using the camera that makes your eyes glow funny colors?
Yep.
But he's out in the dome and it's dark. So we are looking at Saul in the dark, and his camera is an infrared camera. And so it shows him up in a sort of a different way. So we are talking about galaxies tonight. And I want to just share a few slides and show you things like where we are. So let me just add my slides in here so you can see them. I'm seeing that you think it's not too cold in the dome. It is cold and windy here. And so I do not, what's the word? I've lost the word. I'm not jealous of Saul.
Yeah.
He's
I have hot chocolate though.
Hot cocoa or something. So let me show you where we are. Here's a beautiful view of McDonald Observatory, looking in from kind of the northwest. And on your right, you see two mountains, Mount Lock. On your right, you see the mountain with the two domes. That's Mount Lock with our 107-inch and our 82-inch telescope. And on the left, you see the mountain with the shiny silver dome that looks a little like Epcot, and that's our Hobby Eberly telescope. And we are at the Visitor Center, so we are not in either of those places. So we are down here looking at the Visitor Center. This is kind of looking from a lower angle, and let's just zoom in at the Visitor Center. Part of the Visitor Center is a great place to visit. So this is a place for people to come and see us. And actually tonight, Sam and Joe are in the classroom, and Saul is in the dome that's just right there. And Saul will be using his telescope to show us some galaxies. We hope. There have been a couple of technical issues, but hopefully we'll see a galaxy or two or three. And Sam and Joe are going to build a galaxy or build more than one galaxy in the classroom. And if you want to build along with us, you certainly can. We do have our chat open. I see that some people are chatting, so that's good. If you want to say in the chat where you're visiting from, that would be wonderful. Or if you want to ask questions in the chat, we do have moderators who can answer questions. They know lots and lots of things. And if they can't answer a question, they can pass the question over to us. And so we got moderators, and we've got chats, and we've got questions. And we are going to be building galaxies tonight. But what I want to talk about first is exactly what is a galaxy. And I bet some of you are wondering that too. So what is a galaxy? I looked it up. I thought, well, hey, if I want to know what a galaxy is, I need to look it up. And I looked it up, and I found this really nice definition. A galaxy is a huge collection of gas, dust, and billions of stars and their solar systems. And they're all held together by gravity. Well, that's a great definition and I don't like it. So I changed it a little bit. And the reason I changed it is that I'm picky, and that word solar means our sun, our sun. And there's only one of our sun, and its name is Sol. So they're not solar systems. They are officially not solar systems, but they are planetary systems. So let's just change the definition a little bit. A galaxy is a huge collection of gas, dust, billions of stars, and their planetary systems, all held together by gravity. And that definition came from a wonderful website called the NASA Space Place. So the NASA Space Place, I just want to encourage you to visit there, especially if you're here with kids. It's a great place for kids. It's got activities and fun things to do and build. So here's kind of a diagram. The galaxy is in the lower right-hand section of the view, and it looks all spirally and whirlpooly, and that's wonderful. And remember, it's made of stars plus gas and dust, and gravity holds it together. But inside that galaxy, and this must be a picture of our galaxy. You know the name of our galaxy? Our galaxy is called, you can write that in the chat too. I'm not going to tell you the name, but it's named after a candy bar. Our galaxy, and in our galaxy is our solar system. And so there's the sun and some planets orbiting the sun. And so we're on the third planet out, 1, 2, 3. This is some other kind of, I don't know, that's not really Mars colored, but oh well. So that's a nice diagram from the NASA Space Place. So galaxies sometimes look like whirlpools like that. The Snickers galaxy, thank you. That's very wrong. The Milky Way, Tony Fossey got it. All right, so there are other galaxies, and there are a lot of other galaxies, and they're not all spiral galaxies like our Milky Way. So here, I hope you hear, there's a picture. This is the NASA, the Hubble Extreme Deep Field picture. And I want you to look at that picture, and it looks like somebody just spilled a bunch of stuff on the floor, right? Pretty much everything you see in this picture is a galaxy. If you see something that's got little crosshairs on it, like spikes that go up, down, and side to side, that tells us it's a star that's close by. But this is a picture where the Hubble Space Telescope pointed at a tiny piece of space and just stared at it for a long, long time, and everything you see is a galaxy. And the universe is full of so many galaxies. And you can see by looking at this that some of them are shaped like spirals, kind of like the Milky Way. And some of them are just sort of a big glow, a sort of a puffy ball. And some of them are kind of sideways looking. So it's very interesting that the galaxies are all different. Some of them show us different colors. So we're going to be looking at some galaxies. And hopefully we'll get some galaxies pretty soon. All right. Yeah, and if you can't see the chat, do refresh your page, because we had to change a setting on our program when we did it right before the show started. So if you've been in the waiting room and you can't see the chat and you're wondering what I'm talking about, just go ahead and refresh your page. All right. So I want to show you a galaxy, and I'm going to show you a picture that is from where's it from? It's from McDonald Observatory, and this is a picture of a beautiful galaxy. And it was taken by our friend Stephen Hummel. And Stephen Hummel is the dark sky specialist here at McDonald Observatory. And if you look at this galaxy, just take a look at it. Just sort of drink it in and tell me what you see. And Sewell, how are we doing on a live view of this? Sewell,
It's good to go.
Thumbs up. So this is a nice picture. I like to show it to you because it is a color picture. And tonight we're using a black and white camera. So you won't see that there are a few colors showing in this. But so can we see the live view? Oh, I can add it into the stream right here. And take my slides out. Oh, that's my slide. We'll add Sewell in. There we go. All right. So it's a little dimmer, isn't it? Can we stack that and make it brighter? Do you think we'll be able to do that, Sowell?
Kind of with right now with like the wind, probably would come out as nice.
Those are live photons. That's right. That's a live image of that galaxy. What letter is that shaped like? Shaped sort of like the letter S, isn't it? That's for Sam and Sowell. Galaxies in spiral McDonald.
Probably will be better with the next one.
Well, it was bright at first because what you saw at first was a slide. And for the slide, we can take a picture and add stack the images together. So this is live, and this is more like what you would see with your eye on the telescope. But that's this spiral galaxy. It's got that galactic core, which is a big ball of stars, and then surrounding it, this is a barred spiral, so it's got kind of a long straight line, and then spiral arms that spiral around it. So there you go. Oh, it's a Z. Yeah, it kind of is a Z. Wonderful. That's a wonderful live image. Thank you, Sowell. Let's see. One of the things that let me switch over. Let's just go back to the slides for a moment. Let's stick this back in here. And yeah, there we go. That's the slide. So that's the picture from taking a picture with our telescope, that very same telescope, and adding the pictures together. But let me show you a picture that comes from, I think it's from the Hubble. Hang on. There it is. So that's even bigger and brighter, right? That's from the Hubble Space Telescope. The Hubble Space Telescope has this wonderful advantage that it is in space, and so it doesn't have to deal with the atmosphere, looking through the atmosphere. It doesn't have to deal with any of that stuff. It can just stare at this galaxy and take a beautiful picture. One of the things I want you to notice as we look at this is that the center part of the galaxy seems to be sort of more golden and glowy and puffy, and the outer part of the galaxy has got some bright stuff. Galaxies, remember, are stars and gas and dust, and the dark stuff you see in this galaxy, that's dust. So Sam and Joe are going to build their own galaxies, and they are going to use, why don't we put you in the middle right now, Sam? I'm going to just highlight you guys, maybe not. Okay. There's Sam and Joe, and let's see what we've got to build a galaxy with. Can you hold up your black discs? Okay. Sam and Joe have black cardboard discs. Actually, it's poster board, and it's 30 centimeters across, which is about 12 inches, and it's just a circle. And so that's space. And then Sam and Joe also has something puffy to take the part of the stars. And what are you using? Cotton balls. And cotton balls are very nice because we can rip them up a little bit and make them puffier. And what else do you have there, Sam and Joe?
Glue.
Oh, Elmer's glue.
Glitter glue.
Elmer's glue.
Yeah.
And glitter glue.
And glitter glue.
Glitter glue. And glitter glue is wonderful because it makes things sparkly like stars. Now, if you want to play along at home and you have those things, that's wonderful. But maybe you don't have a 30 centimeter disc of black poster board, but a piece of cardboard would work. And maybe you don't have cotton balls, but maybe you can find something like tissue or recycled paper or something like that that's sort of whitish and puffy. And maybe you don't have glitter glue, but maybe you do have some other thing that's smallish and colored. So you can do this. You don't have to have the things that we are using here. But what you might notice when we look at this, I'm going to put this image back in the stream, and Sam and Joe are building galaxies while we're watching the stream here. So in this picture from the Hubble, The stars near the center of the galaxy are looking a little more golden, and the stars near the outer part of the galaxy, out on the spiral arms, are looking more blue. And the reason for that is that stars, newly formed stars, come in all colors, red and blue and white, and colors in between red and blue. But the blue stars don't live for very long. So when you see blue stars, you know that those are stars that are young. So we have young stars in the outer part of the galaxy and old stars, but in the center part of the galaxy, all we have is old stars. And so because stars don't form in the center part of the galaxy. Now, there are galaxies that are other, somebody suggested building a galaxy on a paper plate. That would be perfect. That would be perfect. There are galaxies that are other shapes. So we showed you, we started with a really pretty spiral galaxy, but I want to show you another shape of a galaxy. And this next galaxy is, well, it's actually still a spiral, but it's got more arms there, doesn't it? And this is a galaxy called, hold on, I have it written down over here, but I forgot what it was. It's a galaxy that is NGC 1365. It's another nice spiral galaxy, and it's a beautiful galaxy, isn't it? So it's got, look at it again, it's got older, golder stars, more reddish stars in the center, and bluer stars in the outer part. And you might be saying, but Judy, I see pink stuff in the outer spiral arms of this galaxy. Can you all see the pink stuff in the outer spiral arms of the galaxy? What you're seeing is areas where stars are forming. And when we have a big cloud where stars are forming, the cloud is a cloud of hydrogen. And when we heat up hydrogen, it glows very brightly and looks pink. So it's a little confusing to say our red stars are mostly in the middle of the galaxy and our blue stars are mostly in the outer part. But it's also, what do I want to say? It's also something that we find in the spiral arms of the galaxy, is places where stars are forming. So that's another beautiful galaxy. And when you look at this, can you see some dust? You see the dust in there? Oh yeah, you see pink stuff. Pink is my favorite color. So of course you see pink stuff in the spiral arms of this galaxy. And that's our hydrogen areas where stars are forming. Now dust is going to look kind of brownish, kind of dark brown, just like it does at home. It's just dusty. Yeah. Okay. Well, let me show you another galaxy. I'm just going to move ahead with my slides. Here's a galaxy that is called the Phantom. It's Messier 74. That's its catalog name. And this is a nice picture from our friend Stephen Hummel. But you know what? I'll bet we have a live view of this. So let's just take that out and put this in. And there's the live view of Messier 74, the Phantom Galaxy. Now, this is still kind of dim compared to the sky beyond it. It's called the Phantom because even though it's a galaxy and it's not super far away and stuff like that, it still is, it's difficult for amateur astronomers to reach with their telescopes. And so there's M74. Now, sometimes you hear things called M something or N. We've been putting up the catalog numbers for the things that we're looking at, and I just called this M74. But what I mean is Charles Messier was a French astronomer who was looking for comets back in the 1700s, and he kept finding stuff like this. And he decided at some point to make a list of things that weren't comets after all. And so this is number 74 on Charles Messier's list. The other galaxy that we looked at was NGC 1300, and NGC 1300 is on the new general catalog of faraway things to look at with telescopes. It's not something that Charles Messier saw, but it was, something that someone else is able to observe. Yeah, this is a lovely face-on spiral galaxy, isn't it? And so one of the things that we notice with galaxies is it's brighter in the middle. And so often when we build galaxies with our cotton balls, we start with kind of a big blob of cotton balls to make it brighter in the middle. Sam, can you hold yours up? Oh, Sam made an NGC 1300 there. That's wonderful. Yeah, and brighter in the middle and then spiral arms around it. I'm going to take the live view out of here for now and go back to my slide. That'll give Saul a chance to point the telescope somewhere else. And with this galaxy, especially when we take the picture in color, we're seeing the same things. We're seeing that the stars in the center part of the galaxy are more red and yellow, and that the stars in the outer part of the galaxy, and I've been watching just a little too much Star Wars, I really want to say in the outer rim, but I don't think that's correct. The outer part of the galaxy, they do show up more blue. And then in this image from Stephen, we're seeing some star forming regions, some little pink blobs, and that's Messier 74. I think I have another picture of it here. So let's just see. Oh, here's a close-up view of that galaxy. And this one comes from the La Silla telescope in the Canary Islands. And it was taken because one of the things that we sometimes observe in galaxies is stars exploding. And this picture shows a supernova. And the supernova is that bluish star kind of in the lower left of your view. Way down here. You might be able to see my pointer. It's down in the lower left of the galaxy. The other thing you can see is the dust and the bluish stars out in the spiral arms. That's a lovely picture. But my next view of this is even weirder. One. Ha. Now this is a brand new image, and it comes from the James Webb Space Telescope. And the James Webb Space Telescope, this looks freaky, doesn't it? The James Webb Space Telescope is set up to observe infrared light. So that's not the same kind of light that your eyes can see. It's a longer wavelength, and looking at this galaxy and collecting infrared light from the galaxy, we're seeing it look totally different, right? Isn't that just crazy? So don't put any, what do I want to say? Don't put any importance onto the colors that you're seeing, because they're translating a wavelength of light your eye can't detect into a color that your eye can detect. So it's not exactly the right color, but if we've got our galactic core and they put a bunch of blue stars there, and I love that question from Alina Dopey. Is that how you, that might be how you say your name. And I'll get to it. This is false color, yeah. But isn't that just so interesting that we're able to see stars through the clouds of dust in that galaxy? But then there's also some big kind of void, like big holes in the galaxy. So that's very odd. So here's a question, and I'm just gonna stick the question in here. So the question is, there's galaxies that we see face on and edge on and other shapes of galaxies, elliptical, etc. Are there galaxies that we see from the underside? Or is that not possible? And the answer is the top side is the same as the bottoms. I mean, it's okay. The only difference, if we could see this galaxy we can't see it from the other side because we would have to travel millions of light years away, right? But we can see other galaxies, and we know that galaxies are pretty much the same on the top and the bottom of the spiral arms. Does that make sense? I hope that makes sense. Yeah. All right. So that was a weird looking view from the James Webb Space Telescope, and this was data that was processed by somebody named Judy Schmidt, and I like that name because it's Judy. All right. So let's move on. See what else we have. All right. So here is a beautiful picture of another galaxy. And this other galaxy is a galaxy that is on the what do I want to? Oh, on the NGC catalog, it's NGC 7331. And this was a lovely picture taken by Adam Block at the University of Arizona in Arizona. And when we look at this galaxy, we're looking at it kind of from the edge, right? We're not seeing it face on this time. It's tilted. It's shaped a little like a plate, and you can see the dust lanes, especially around the outer edge of the facing edge of this galaxy. And the other thing you might notice in this image is that there are other galaxies in the view, right? You all see other galaxies? Hey, how many galaxies do you see? Why don't you count the galaxies that you can see in this picture and throw that number into the chat. Oh, goodness. I'm watching Sam and Joe in the classroom, and Sam is just a galaxy-making machine here.
Joe's finished his.
Yeah, I've got one. Here's
NGC 7331. That's correct. How many other galaxies do you see, though?
2 with Joe.
7331 is in an area, in a region that has other galaxies. 9,862. I'm seeing at least 3 more that are very prominent in the view, and someone's seeing 8, so that's good. Wow. Let's see, do I have another picture? I don't know. Oh, yes. And this is our nearest neighboring galaxy. But I want to know I don't want to do this one yet, so I'm going to go back. I'm going to go and see what Saul's got up, because I see that he's got something bright here for us. So let's just stick Saul's image in here. There we go. Does that look familiar? Does that look like NGC 7331 to you? But isn't everything we see are galaxies? Everything we see is part of a galaxy. But here we're looking at 7331. The image is a little bit tilted from my slide, but you can also see at least 3 galaxies in the background. That's very nice, Saul. Thank you. That's lovely. Okay, so what I want to do now is I'm going to take Saul's image off the screen just so he can point the telescope to the next thing. And I want to go back to the classroom. And I want Sam and Joe to tell us what you've made so far. Can you do that?
Yeah.
Galaxies. Hold on.
Concentrating on the
Yeah.
red.
Okay. You should probably unmute yourselves.
Oh,
Are you unmuted?
We are unmuted.
now we are.
We were. Okay. Well, I got
No. No sound from Sam and Joe.
Are you muted?
What are you doing? I'm unmuted.
Nah, y'all are good. It's on Judy's
Oh.
end.
Oh,
I can
hey. Look
Ah,
at
there
us.
we go.
I was going to say, we were unmuted the whole
Yeah.
time. And more puffy spiral
Yeah.
galaxies.
Here's the first one I made here. And here's, oops, I got glitter on me. Hello.
Glitter everywhere.
Yeah, and then here's another one I made right here. So,
And
Yeah.
I'm getting started with the next one
yeah.
with the center.
And yep, I'll get glitter. So,
And just covered in glitter at this point.
yeah. It's glitter glue, so it's not that bad.
No, but it's
Yeah.
everywhere.
I guess I can hang it on our shirt too. Okay. Anyway, so that's, yeah. The step.
So my question for you is, how many galaxies have you made?
I've made 2.
I've made 2.
6? 5?
Hmm?
12?
There's 4.
All of them. And there's a galaxy poster behind you.
Oh yeah.
Yeah, our friend Spiral McDonald made us plenty of black discs. And so Sam and Joe are just going for
Yep.
it. I think that's wonderful.
Piece,
Thank you so much.
Oh, there's another one.
There's 4 here.
Oh, okay. Well,
All right.
Like 3.
Okay.
And you can see what they're doing. They're starting with kind of a ball of
Cotton balls, I guess.
cotton balls and then adding spiral arms and then adding glitter glue to the outside edges.
Oh, how would I know? What half of our supplies are.
Yeah.
It's okay. We
It's
got
like
something
fun,
else.
guys.
We may run out of
Great.
We're going to run out of cotton balls before whatever.
We're doing great.
All right, I'm gonna turn you guys back off and go back to my slide. So this is NGC 7331. It's a beautiful spiral galaxy, kind of edge on. The nearest galaxy to us that's a spiral is, we need tens of billions, please, of, yeah, right. Sam and Joe and the Big Bang. You guys are funny. So our nearest spiral galaxy neighbor is the Andromeda Galaxy. And this is a really lovely image of the Andromeda Galaxy. The Andromeda Galaxy is a galaxy that you can see with your eyes without needing a whole lot of instruction. You just have to figure out how to find it. It is our closest spiral galaxy. It's only 2.5 million light years away from us. 2.5 million light years isn't very far compared to the size of the galaxy. And so yeah, and we've got a question from Linda C that says, it's going to pop up here. I think. Come on. There. How far away is the Andromeda Galaxy? And is our galaxy going to interact with it in our lifetime? The Andromeda Galaxy is 2.5 million light years away from us. And it is going to interact with us it is interacting with us right now. It's just a very faint interaction right now. It's 2.5 million light years away from us, which is close. And it's got a halo of influence that reaches as far as the halo of influence that reaches around the Milky Way. And so they're feeling each other right now. Andromeda and the Milky Way are headed towards each other and will reach each other and interact in the future. But that's no time soon. The future is a long time from now. The future is about 5 billion light years. I mean, 5 billion years, not light years. Yeah. And I have a video to show you, and I would love to show it, and I hope it works. So in our lifetime, we won't see much difference at all, Linda. Sorry. It would be very cool if we could, but we won't. So let's get this in here, this video, and see. Okay, so this is a simulation. What we're seeing is 2 galaxies that could be the Andromeda Galaxy and the Milky Way, and they reach each other, and their gravity pulls streams of stars off of each other, and they do this beautiful dance. And what we end up with after the 2 galaxies do a beautiful dance is kind of a big, ugly puffball of a galaxy. So they will end up combining their stars and becoming what we call an elliptical galaxy that is just kind of a ball of stars. but that'll happen in about 7 billion years. So that is a very long while, and we're not going to worry too much about it. A blender dance. Yeah, it's kind of a blender dance. All right, so that was a nice video from the NASA Advanced Visualization. Let's get that. Oh, I didn't mean to start it over. Hang on, stop. Okay. And Sewell has a live view of Andromeda. Yes? I muted you. I don't know. So Sewell has a live view of Andromeda, the galaxy. And Sewell, can you tell us what you're seeing?
Yep. So here we got the Andromeda Galaxy, but so close to us, it's so big in the night sky that it can't even fit in the field of view. The giant glaring light there is the core of the galaxy, where most of the stars of the Andromeda Galaxy are in. And kind of like the dark streaks you see are actually some of the gas. It's like thick enough that actually blocking out some of the light. So we can't fit the entire thing in view. It's so close to us. And it's just, as Julie says, just getting closer and closer to us. Yep. Let's see. And also saw someone, Dick Dingle, say, will it be called the Milky Drama Galaxy? There's debate about the names. Some people are saying it'll be called the Milk Dromeda. There's also petitions for the Andromeda Way. Good thing we got about 5 billion years to come up with a better name. And yeah, how are the galaxies coming along, Sam and Joe?
Pretty good.
Nice.
I'm on my last one. You're working on your third?
Yeah, I'm almost.
We're getting there.
Yep.
We'll be there. I like the Sam and Joe Big Bang. That was fun. That was fun.
It's creation of all the galaxies. Where the galaxies come from, just Joe and Sam are building them together.
Oops, don't use glue.
I think I'm having more fun just making a mess at this point.
Yeah, I'm kind of making a mess here too.
My hands are very glittery. So.
Shouldn't have wore black with glitter. Oh well.
No, not really. It's not a good idea. The Texas Galaxy.
Or-
Oh, hey, Perseus Galaxy.
Ooh, that would be nice.
I like
Ooh,
that.
Uh-huh.
yeah.
Look at
Oh,
that.
here's a question from Charlie Ondrej. I hope I'm pronouncing that correctly. Will the black holes merge? So yeah, when galaxies collide, their black holes will eventually merge and form a larger black hole. So the black hole would just get bigger.
Our universe is getting flooded right now.
Oops.
Y'all.
Yeah. And also, if y'all are wondering how long this image has been going on for, right now the exposure is about a minute, and we're doing what's called live stacking. So we're just kind of putting images on top of each other to actually make them better overall. Yeah. Let's see if there are any other questions that have come in. Yeah. And also, it's very windy in here. But yeah, some little things about the Andromeda Galaxy. Well, as Julie said, it's very big. It's coming towards us. And kind of the reason it looks so fuzzy is, as I mentioned, it's really close to us. It's really big, and galaxies are basically clouds with a bunch of gas and dust and stars. And at this distance, the stars look very blurry. And it looks almost dusty and cloudy of sorts. Yeah. Yep. Are you good to go, Julie?
Yeah, I have mic issues, so I have to turn off my mic while you guys are talking. Oh, right. So that is a bit of the Andromeda Galaxy, but not very much, right? And but I love that I can see kind of filaments, dark filaments of dust, because remember, galaxies are made of stars and gas and dust. And so we're seeing the light from the stars plus the dust. And that's very wonderful. I really don't have any more slides except for my ending slides. So now is the time for us to answer questions. So people with the chat, I hope you'll ask us some questions, because otherwise we'll have to think of them ourselves, and who knows where we're going. I do see a big long question about UFOs, and this is a live stream about galaxies, and so the UFOs are going to have to wait for another time. Messier 32 would be a beautiful elliptical. Yes, it would. But we decided to look at the spiral galaxies tonight, so no ellipticals. No, hold on. There's my slide back. Let's see, what else can we say? You can even say it glows. So with our view of our live view of the Andromeda Galaxy, we were looking right in the middle and seeing some of that dust and not most of the rest of the galaxy. So please ask questions in the chat. Thank you for the information from the ages to the ages. Yes, thank you. I'm gonna take the slides off just so we have our faces. And did Sam go to get that one last galaxy? Joe's not going to talk.
I think so. Well, Sam's not there, so I'm assuming she went to go grab that last galaxy.
Well, other questions? Any questions? Joe, what's your favorite galaxy?
Y'all are muted.
Sorry.
Okay, can you hear us now?
Yeah, favorite galaxy. I like M82.
What you got, Sam?
I got a cake because it is someone's birthday here today, so we're
We're
celebrating.
going to make an edible galaxy.
Mm-hmm.
Aww.
All right.
I'm gonna mute us because this is gonna be loud.
All right.
I'm gonna mute us because this is gonna be loud.
All right.
I'm gonna mute us because this is gonna be loud.
All right. Well, that's another way to make a galaxy. All right.
Yeah, so here's a question from S. Riley. What do you recommend for someone who wants to try to view galaxies from the backyard? When is the best time? Let's see. I think that might be more a question for you, Joe. You probably know your way around the night sky a bit.
The best time to view galaxies in the northern hemisphere is in the spring. There are many, you can see there are some bright ones you have to get. The trick to see the galaxies, you have to be in dark skies away from city lights. So springtime is the best.
Thank you. And also from Joe Lagota, what capture software we're running? Right now we're running Sharpcap, which is the name of the software. It works pretty well on the camera we have right now. Attach will also probably add to the description if it's not there already. But ZWO monochrome camera. And yeah, I believe that's. I don't know if we have any more questions.
Oops. I'll pick them up later.
What'd you do?
I spilled sprinkles.
Oh, okay.
Oops.
Ooh, a little galaxy cake.
Yeah, you got Galaxy sprinkles. Well, what I'm calling Galaxy sprinkles because this is all they had at the store.
See, if you didn't have any construction paper on hand, you could use your baking skills.
Anything.
Bake a cake.
So we got candles and everything too.
Oh, wow.
Yep.
Aw, thank you. All right. See, I don't really see many other questions coming in. So, Julie, you want to take it away? So, Julie.
Yes. Yeah. Thank you all for coming, and I hope you'll come back again. I've got 2 more slides to show you, and there are ending slides. So, ooh, and it just went away. Hold on. There we go. So there's a beautiful picture of Andromeda. Thank you for joining us today. There are lots of ways to connect with McDonald Observatory. You can connect with us through our website, mcdonaldobservatory.org. There's a link to our gift shop. Stardate.org is also a thing, but this program comes to you from the K-12 education team. And so we have more slides from that, but that's not it. They are somewhere else that I've lost. So come and see us, and thank you all for joining us, and clear skies, everybody. Let's go have some cake. Bye.